Good morning, friends. Today, I want to solve some more problems from last year's test paper of CBSE Mathematics Standard subject. In my last lecture, I have solved up to the trigonometric problem, and then we'll continue from the next onwards. That is 22nd, I think. So let us look at that question. Yeah, I am solving from the coded paper 30/S/3, and in my last lecture, I have solved this problem of trigonometry. That is question number 27. I solved question number 27, and and I'm not much interested in statistics problems. If time allows, I may come back to them. I'll go to analysis problems. That is, I'll go to question number 29. Right. If alpha beta, alpha beta are the zeros of the polynomial p of x equal to x square minus 2x minus 3, then find a polynomial where zeros are 2 alpha plus 3 beta and 3 alpha plus 2 beta. So we are given this quadratic polynomial. We have to find the roots of this polynomial. How can we do that? We will factorize this. C into A, C is A, we compare this with ax square plus bx plus c, we obtain A equal to 1, B equal to minus 2, and C equal to minus 3. C into A is minus 3. And minus 3 has factors minus 3 plus into 1 plus 1, whose sum is minus 2. So that helps us factorize this. From that, we can get alpha and beta. Once we know the values of alpha and beta, we can calculate what is 2 alpha plus beta and what is 3 alpha plus beta. And from there, if this is some x, if this is some gamma and delta, the corresponding polynomial will be x minus gamma into x minus delta. Okay, so let's look into the working. This polynomial is x square minus 2x minus 3. Yeah. X square minus 2x minus 3. X square minus 2x minus 3. This is question number 28. Okay. So this is question number. Yeah. X square minus 2x minus 3. Question number 29. X square minus 2x minus 3. Yeah. We need 2 alpha plus 3 beta and 3 alpha plus 2 beta. Yeah. So let us factorize, make this equal to 0. Let us factorize this quadratic polynomial. Okay. We'll compare this with the standard polynomials x square plus bx plus c equal to 0. We get a equal to 1. Coefficient of x square is a. Here it is 1. And coefficient of x is b. That is minus 2. And coefficient c is minus 3. Okay, that is constant. So it is minus 3. So, and product AC is equal to 1 into minus 3. Okay. And 1 means it is plus 1. Plus 1 into minus 3. And we have the sum of these two factors, plus 1 plus minus 3 is equal to minus 2. Is equal to minus 2. This coefficient B. Okay. So writing minus 2 as 1 plus minus 3 helps us factorize this. Therefore, x square minus 2x minus 3 is equal to x square minus, for minus 2 we are writing 1 plus minus 3. 1 plus minus 3. Okay. into x, this is plus minus 3 equal to 0. Okay. I have written minus 2 as 1 plus minus 3. Okay. Minus 2. It is for minus 2, I have written 1 plus minus 3. 1 plus minus 3 is minus 2. So x is x square minus 2x. Minus 2 is equal to 1 plus minus 3 is minus 2 into plus is minus 2 into x minus 3. Okay. So this becomes x square plus 1 into x is plus x, and then plus into minus 3 is minus 3. Okay, this can be erased. Yeah, and minus 3x, minus 3. Okay, plus 1 into x is x, plus into minus 3 is minus 3 into x, and then minus 3. This is, in these two, you can take x common. X into x plus 1. In these two, you can take minus 3 common. Minus 3 into x plus 1. Minus 3 is out, x remains. Minus 3 is out, plus 1 remains. Here x is out, x remains, plus x is out, 1 remains. So between these two, we can take x plus 1 common. So x plus 1. In this expression and in this expression, x plus 1 factor x plus 1 is common, take it out. What remains is x minus, this is out, x plus 1 is out, minus 3. So this quadratic could be factorized as x plus 1 into x minus 3. So we'll make this is equal to 0. So from here we get the roots. Okay. Either x plus 1 equal to 0, that gives you minus 1, or x minus 3 equal to 0, that gives you 3. You have to treat these as numbers. A into B, some h into k is 0. This is h some k. H into k is 0. H and k are numbers. This is h, this is k. They are numbers. Product of two numbers is 0 if and only if one of them is 0. Okay. So x plus 1 becomes 0, that gives you minus 1, or x minus 3 equal to 0 gives you x equal to 3. So these are the roots of the given quadratic polynomial. Okay. So therefore, let alpha be equal to minus 1 and beta is equal to 3. Okay, I'm calling this alpha and this beta. You can call otherwise also. You may call this beta or this alpha. Okay, yeah. So, and we have to form 2 alpha plus 3 beta and 3 alpha plus beta. Let us write that. These are the roots of this given quadratic polynomial. Okay, so thus alpha equal to minus 1 comma beta equal to 3 are the roots of the given quadratic polynomial. Okay. Now let us form 2 alpha plus let us form 2 alpha plus 3 beta and 3 alpha plus 2 beta. So therefore now 2 alpha plus 3 beta. 2 alpha plus 3 beta is equal to 2 into, for alpha substitute minus 1, and for beta, you write 3. Right? This is 9 minus 2 is 7. Okay? For alpha I'm writing minus 1, and for beta I'm writing 3. So this is minus 2 plus 9, that is 7. Okay? Now, similarly, let us calculate 3 alpha plus 2 beta. 3 alpha plus 2 beta. This is equal to, right? 3 into alpha is minus 1. Substitute for minus 1 for alpha and substitute 3 for beta. So 2 into 3. So this is right. For alpha I'm writing minus 1. For beta I'm writing 3. So this simplifies to, this is minus 3 plus 6 is 3. This is 6 minus 3 is 3. Now the quadratic polynomial, the quadratic having roots 2 alpha plus 3 beta and 3 alpha plus 2 beta. 3 alpha plus 2 beta is, so we want the quadratic polynomial for which 2 alpha plus 3 beta and 3 alpha plus 2 beta are roots. So we want quadratic polynomial for which roots are 7 and 3. That is x minus 3, x minus of this into x minus of this, x minus 7. Okay, you expand this. You subtract 7 from x and subtract 3 from x, and you get two linear factors, multiply them. You get the required quadratic. So expand this. X into x is x square, minus 3x minus 7x is minus 10x, and then plus 3, minus into minus, plus 3 into 7 is 21. Okay. X into x is x square, minus 3 into x, minus 7 into x is minus 10x. And then this is minus 3 into minus 7 is plus 21. So this is the required quadratic. Okay. So what we have done, we are given quadratic. We are given a quadratic polynomial. Okay. Right. We are given a quadratic polynomial p of x. Okay. And for this, we have computed alpha and beta, and we are asked to form the quadratic polynomial whose roots are 2 alpha plus 3 beta and 3 alpha plus 2 beta, where alpha and beta are the roots of this. Okay. This is actually p of x. So, so this is p of x. So, p of x. Okay. The name for this is p of x. So what we have done, for p of x, yeah, equal to x square minus 2x minus 3, make it equal to 0 and solve this equation. We have factorized this. This becomes minus 3 becomes minus 3 plus 1. So it is x minus 3 into x plus 1. Okay. That's what I have obtained, x minus 3 into x plus 1. Right. The point is, here a is 1, c is minus 1. You compare this with its standard quadratic polynomial. A is 1, b is minus 2, and c is minus 3. And product of a and c is 1 into minus 3, that is minus 3. That minus 3 should be written as product of two factors whose sum is minus 2. That is minus 3 and 1 are factors of minus 3, which is AC, and sum of 1 and plus 1 and minus 3 is minus 2. So if you write like that, if you write minus 2 as this, you will be able to factorize this quadratic. Okay, that's what we have done. This gives x square minus 2x minus 3. Okay, and make it equal to 0. So from here you get x, this is 0 means x is minus 1, or this is 0 means x is 3. These become the roots of this quadratic polynomial p of x equal to 0. Okay, you name one of these to be alpha and the other to be beta. So alpha is minus 1, beta is 3. You can as well name alpha to be this or beta to be this. There's nothing wrong. Okay, then yeah. So these are the roots of the given quadratic polynomial p of x. Given quadratic p of x. Okay. Now you're asked to find the quadratic whose roots are 2 alpha plus 3 beta and 3 alpha plus 2 beta. In this, you substitute the values of minus 1 and 3. 2 into minus 1 is minus 2, plus 3 into 3 is 9, minus 2 plus 9 is 7. So 2 alpha plus 3 beta is 7, and 3 alpha plus 2 beta. For alpha you write minus 1, for beta you write 3. So this 6 minus 3 is 3. So you have to find the quadratic whose roots are 7 and 3. Right? So how can you find this? It is nothing but you subtract this from 3, you get x minus 3, and you subtract 7 from 3. If 7 from x, you get x minus 7. These are linear polynomials. You multiply them, you get a quadratic polynomial. And for this, roots will be, when this is 0 means for x equal to 3, and when this is 0 when x is 7. Means for this, roots will be 7 and 3, means roots will be 2 alpha plus 3 beta and 3 alpha plus 2 beta. Okay. The quadratic polynomial having these roots is the product of these two. Multiply these. X into x is x square, minus 3x, minus 7x is minus 10x, minus 3 into minus 7 is plus 21. So this is the required polynomial. Okay. Yeah. So let us move to the next question. That is 30. Question number 30. Yeah. Question number 30. Ranjita, Neha, and Salma start weaving sweaters at the same time for the children of an orphan home. They need 15, 18, and 20 days respectively to complete a sweater. After how many days will all of them start making a new sweater again? By what? By that time, how many sweaters will have been completed by them? Okay, so Ranjita makes a sweater in 15 days, and Neha makes in 18 days, and Salman makes in 20 days. Respectively means like that you have to take in that order you have to take. Okay. Now, so once they start simultaneously, right? Uh, they start weaving sweaters. They start weaving sweaters. At a particular time, then when can they again start together? Means first of all they have to complete. Once they start, when can they complete for the first time? That becomes the LCM of all these. Okay. So by the end of that time, LCM of time, they will be completing theirs. Right? All of them will be together completing sweaters. Some will be competing. The sweaters they weave by the time of LCM days may be differing. But once they are starting at one particular time, again when they start new sweaters, that the next particular time of all of them starting weaving of new sweaters becomes the LCM of all this. Okay, so we'll calculate LCM. That gives us all of them start making a new sweater again after that many days. Okay, by that time, how many sweaters will have been completed by them? Means we'll be dividing LCM by this to get the sweaters Ranjita made, and LCM divided by this gives the sweaters Neha weaved, and LCM divided by this gives us Salma gives us these sweaters Salma has weaved. So let's go for the LCM of 15, 18, and 20. Question number 30. Question number 30. It is 15, 18, and 20. Yeah, 15. It is 15, 18, 20. Okay, Ranjita, Neha, Salma. 15, 18, 20. Yeah, Ranjita, Neha, Salma. Weave sweaters in 15, in 15, 15, comma, 18, comma, 20 days, respectively. Okay. Let us find the LCM of these three. These three numbers. Okay. We have 15, and then 18, and then 20. Right? 3 cancels in these two. You don't need to go for the common factor of all these. It is enough if you have a common factor for 2 of these 3 numbers. 3 divides 15, 3 divides 18. So you get 5, and here you get 6. You write as it is. Okay. Now these 2 are even, so 2 divides. So here comes 5, here comes 3. 2 divides 6 3 times, 2 divides 10, 20 10 times. Okay, these two have common factor, that is 5. 5 divides 5 one time, and 3 comes as it is. 5 divides 10 two times. And these are prime numbers. 3 and 2 are prime numbers. And this is ikai 1. Okay. Therefore, the division is over. Therefore, LCM of 15, 18, 20 is equal to product of all these into these. That is 3 into 2 into 5 into 3 into 2. That is 3 square into 2 square into 5. Okay. This is 9 into 4 into 5 is 20 into 9 is 180. Right? 4 into 5 is 20 into 9 is 180. Yeah, that is true. What is the least common multiple of 15 and 20? It is, the multiples of 20 are 40, 60. So it is 60. Common multiples of 15 and 20 are 60. And then 60 is not a multiple of 18. So multiple of 60 are 120 and 180. 180 becomes a divisor of 18. That's how 180 becomes LCM of these three. Okay. Once we get this, therefore, in 180 days, those three start weaving new sweaters. Start weaving new sweaters. Okay. Yeah. So we are asked another question. In these many days, how many sweaters those three would have weaved? Okay. In 180 days, Ranjita the weaved sweaters equal to, that is 180 divided by the days Ranjita takes to weave a sweater, that is 15. Okay, so this is 12. These many sweaters she weaves in 180 days. And similarly, Neha weaves how many sweaters in 180 days? Yeah, for one sweater she takes 18. In 180 days she weaves how many sweaters? This by this, that is 10 sweaters. Okay, and in 180 days Salma weaves how many sweaters? That is 180 divided by 20. For one sweater, she takes 20 days. For 180 days, how many sweaters can she weave? Divide this by 20. You get 9. Okay. So these are the number of sweaters weaved by Ranjita, Neha, Salma, respectively in 180 days. Okay. So that completes the solution. So what we have done? Yeah. We are given that Ranjita, Neha, Salma weave a sweater each. Weave a sweater each in 15 days, 18 days, 20 days respectively. Neha weaves one sweater in 15 days. Salma weaves in 18 days. Ranjita weaves in 15 days. Neha weaves in 18 days and Salma weaves in 20 days. A sweater each. Okay. And we are asked if all of them start at the same point of time, when they again start weaving a new sweater. So for that you have to go for the LCM of all this. So I have calculated. First you go for the common factor of all these three. There is none. This is 3 square into 2. So 2 is not a factor of this. So 3 is not a factor of this. So we don't have a common factor. Still, if for 2 of these numbers you have a factor, go for that. 3 divides this. So 5 times, 6 times, and then 2 divides these two, 3 times, 10 times, and then 5 divides these two, 1 time, 2 time, and the 3 take 3 as it is. Now you are left with prime numbers here, 1 is allowed. Now LCM becomes the product of all these. Okay, these as well as this. That's how you get LCM of these three given numbers is equal to 180. Now, therefore, in 180 days, those three people start weaving new sweaters. Okay, again, that also is important. Again. Okay. Now, if the another part, question is that in these many days, how many sweaters they would have weaved individually? Okay. So for that, what we have to do? You have to divide 180 by the sweaters they weave, the time they take individually. In all, this is 180 days. For 15 days, they take. In 15 days they weave one sweater. So in these many days, this by this equal to that many sweaters they weave. Okay, so Rajita weaves. How about Neha? Neha takes 18 days to weave one sweater. In 118 days, she can weave 180 by 18, that is 10 sweaters. And Salma weaves one sweater in 20 days. In 118 days, 180 days, she weaves 180 by 20, that is 9. Okay, so these many sweaters, Ranjita, Neha, Salma weave in 180 days respectively. That is 12, 10, 9 respectively. Okay, this completes the next question. So let's go for the 31st question. Yeah, 31st. Check graphically whether the pair of linear equations 2x plus 3y equal to 12, 5x minus 3y equal to 9 is consistent. Okay. What we have to do is, these are linear equations in x and y. They stand for straight lines. This is a linear equation. The degrees of x and y are 1, 1. So this is a linear equation in x and y. Therefore, represents a straight line. Similarly, the powers of x and y are 1s. So this is the first degree equation in x and y. Therefore, this represents a straight line in the xy plane. Now, you take 2 points for this line. Okay. For example, you take x equal to 0, you get corresponding y. You take y equal to 0, you get corresponding x. Like that, you can take any 2 points that belong to this line. Means that satisfy this equation. Once you get 2 points, you can join them with a straight line. Similarly, you get 2 points which satisfy this equation. You can take x equal to 0, you get corresponding y, and then go for y equal to 0, you get corresponding x. Okay, so you can take any number of points you want, but to determine a straight line, 2 points are enough. Okay, so you take at least 2 points that satisfy this second equation also. So once you know the coordinates of those 2 points, you can join them with a line segment, with a line segment that becomes the part of this line. Okay, and we have to show that this system, these two equations are consistent. Means that we should be we may be getting, we may be getting two intersecting lines. That shows they are consistent. Okay, so let's do this using graph. So you have to take a graph sheet from your invigilator, and then on the graph sheet you mark x-axis, this is called this O, x dash, and then y-axis O, y dash. Okay, and then and then for every centimeter you mark numbers. Okay, on the right side you take 1, 2, 3 and so on. On this x-axis you take scale equal to 1 centimeter is equal to 1 centimeter is equal to 1 unit. Okay, on both coordinate axes. Okay, this is the scale you may take. Okay, and on the left hand side of origin, for 1 centimeter you mark -1, for next centimeter you mark -2, for next centimeter you mark -3 and so on. Okay, so you have to mark these numbers 1, 2, 3, 4, 0 and 1, -1, -2, -3 on the number line x-axis. Similarly, you do it for y-axis. Okay, for every centimeter you mark above this x-axis 1, 2, 3 and so on. This becomes 1. And for the next centimeter, mark 2, next centimeter, you mark 3, and so on. And below the x-axis, you mark -1 for the first centimeter, and -2 for second centimeter, and -3 for third centimeter, and so on. Okay. Now here you take y equal to 0, and then when y is 0, this becomes 3 into 0 is 0, means 2x. 2x plus 0 is 2x. 2x is 12, so x becomes 6. Similarly, you take x equal to 0. Substitute 0 for x. So 2 into 0 is 0. 3y plus 0 is 3y. So y becomes 4. 3y is 12. Y becomes 4. So, and this is a straight line in the xy plane. Two distinct points are enough to determine this. Similarly, the second equation is 5x minus 3y equal to 0. You take x, y equal to 0. So this is 3 into y is 0 minus 0. This becomes, and 5x minus 0 is 5x. So 5x is 9. So x becomes 9 by 5. And if you take x equal to 0, this is 0 minus 3y is minus 3y. Minus 3y is 9. So y becomes minus 3. Minus 3 cancels in 9 minus 3 times. Therefore, y becomes minus 3. So, right? Yeah. You have taken 0 here. And then this is minus 3, y is 9. Minus 3 cancels in this minus 3 times. So y is minus 3. Right? Yeah. So here also you have got two distinct points. The ordered pairs x comma y, that makes one line, one point, and this makes another point. You call this point A, and this point B, and this point C, and this point D. You mark A equal to, yeah, consider A is equal to x comma 0. Order is important. You have to take x comma y here. And then B equal to 0 comma 4. First you take x coordinate and then take y coordinate. Similarly, you take C equal to x coordinate is 9 by 5 and y coordinate is 0, and D is equal to x coordinate is 0 and y coordinate is minus 3. Okay, so you have got 4 points. You have to mark these on the xy plane. Okay, now x coordinate is 6 comma 0. Where is this 6 comma 0? Somewhere here. This is right here. So let me extend this line, this x-axis. Okay. Yeah. I have extended it and then mark 6 here. Yeah. This is 6. This is 5. This is 6. Right? You need 6 comma 0. Means that on the x-axis, the y coordinate is 0. So this point here will be on x-axis. So it will be this. The required point will be this. This is capital A. Okay. Let me erase. Yeah. So what is capital B? What is capital B? 0 comma 4. X coordinate is 0, so it will be on y-axis. So this is B. So this is B comma. This is the 0 comma 4. Okay. This is A. This is 6 comma 0. Okay. Now you can join A and B with a line segment with the help of scale and pencil. Okay. And you may extend this. Yeah. Okay. Now you mark D. You mark D. Yeah. You mark C 9 by 5 comma 0. Yeah. What is C 9 by 5 comma 0? Y coordinate is 0, so it is an x-axis. X coordinate is 9 by 5. 9 by 5 is 1/4 by 5. That is 1.8. It is 1.8. It will be somewhere here. Okay, this is what? This is the point C. C? Yeah, C. 9 by 5, comma 0. Okay, this is C. And then D 0, comma minus 3. X coordinate is 0, means it will be on my axis. It is minus 3. It is this. This is 0, comma minus 3. Okay, this is D. This is D. Now you join C and D with the help of a line segment. Okay, now What is this? You extend this on both sides. Yeah, you extend this on this side also. Yeah. So we have drawn, yeah. Uh, mm, right? Let us call this number one. Let us call this equation number one. Let us call this equation number two. So number one, this line represents the first equation, and this equation represents this second line. Okay. Uh, so okay, this straight line represents the second line, and they are intersecting at this point. What are its coordinates? 3, 2. Okay, you locate this point. Okay, that is, call it some E. Its coordinates are, x coordinate is 3 and y coordinate is 2. Okay, right? So that is how you can find the location of three intersecting lines. Okay, the given system of linear equations in x and y, right? For those equations, we have drawn straight lines in the xy plane, and those two straight lines are intersecting at this point E with coordinates 3, 2. And this becomes a solution for these simultaneous equations. Means these two are consistent. Okay. In fact, x equal to 3, y equal to 2 becomes a solution for these two equations simultaneously. Okay. And I think we are also asked the solution. Solution becomes therefore solution for the given system of equations is equal to capital E 3, 2. Means what? Means simplifies x equal to 3, y equal to 2 is the solution of the given equations 1, 2. Okay. So you take x equal to 3 and y equal to 2. That becomes the solution of the given system of equations. Right? So let's look at the question. Question number 30. Yeah. If so, solve it graphically. Yeah, we solved it. We solved it graphically. Okay, we solved it graphically. This completes. Let's look at the next question. Question number 32 or 31? Yeah, it is this. It is 31B. 31B. Yeah. A two-digit number is obtained by either multiplying the sum of the digits by 7 and then adding 3, or by multiplying the difference of the digits by 19 and then subtracting it. Subtraction 1. It is given that the digit at tens place is greater than that of units place. Find the two-digit number. Yeah. So we proceed like this. This is question number 32. Question number 32. Okay. Yeah. Let x comma y be the number required with x comma y. See, for example, 97 is written as right. This written like this. In units place you have 7, and in tens place you have 9. So I am taking digit y in the units place and digit x in the x in the tens place, where with x. So let xy be the number required with x comma y digits as digits in tens comma units place, units places respectively. Okay, I'm taking x in tens place and y in units place. I'm taking x in tens place and y in units place. Okay, so yeah, So this is the number. What does this mean? X into 10 plus y. Okay, y into 1. Right? The number value of this is x into its place value 10 plus y into its place value 1. That is y. So this is 10x plus y. Okay, and this is given in terms of some variables. What is it? Let us see. Yeah. Uh, the sum of the digits, uh, a two-digit number is obtained by either multiplying the sum of the digits, that is x plus y, by 7 and then adding 3. Yeah. So it becomes how much? This is equal to x plus 7, x plus y plus 7. Okay. Or it is also equal to, means 10x plus y is equal to, yeah. So it is equal to, or by multiplying the difference of the digits by 19, that is x minus 5 into 19, then subtracting 1. That is x minus y into 19 and subtracting 1. Okay. What are we given? Right. So a two-digit number is obtained either by multiplying the sum of the digits, means x plus y into 7 and then adding 3. Plus, that is 7 into x plus y plus 3. Okay. That is 7 into x plus y plus 3. Oh, I'm sorry. So this is plus 3. I'm sorry. This is 3. Yeah. Okay. And then, where is this? Okay. And then it is also equal to, yeah, the difference is multiplied with 19, subtracted 1 from that. Uh, so, the diff, so, or, right? Multiplying the sum of the digits by 7 and then adding 3. That is 7 into x plus y plus 3, or multiplying the difference of the digits, that is x minus y, by 19. 19 into that, 19 into x minus y minus 1. Minus 1. Okay. This number is obtained by either this way or this way. So that is it. The number is equal to 19 into x minus y minus 1. So this is 7 into x plus y plus 3. Okay. 19 into x minus y minus 1. Yeah. So this gives one equation in x and y. This gives another equation in x and y. We have to solve. We have to solve those two equations. Okay. So let us consider first equation. What does this mean? 7x minus 7, 10x minus 7x is 3x. And then y plus 7y means 7 minus 6y is equal to 3. Okay, 10x, this is 7x, take to the other side, 10x minus 7x is 3x, plus y, take it to the other side, 7y minus y is 6y, I'm sorry. Okay, you bring it to this side, minus 6y. Means 7y, when it is brought to left hand side, it becomes plus y minus 7y, that is minus 6y, is equal to 3 remains here. How about the second equation? Second equation is, this is 19x. Take 10x to the other side. 19x minus 10x is 9x. And then take y to the other side. Minus 19y minus y, that is minus 20y, is equal to minus 1. Okay? If minus this goes to the other side, it becomes plus 1. It is 1. Okay? This is 19 into x. 19x, bring 10x to the other side. 19x minus 10x is 9x. And then minus 19y. Take y to the other side. It becomes minus 20y. And take minus y to this side. That becomes plus 1. Okay. It is on the other side of 19x. Okay. So it becomes plus 1. So these are the two equations we have got. Now we have to solve these equations. How can we solve? Yeah. You multiply this by 3 and subtract. Right. 1 into 1 into 3 gives you what? 9x minus 6y minus 18y is equal to 9. I am subtracting this equation throughout by 3. So 3 into 3x is 9x, and then minus 6y into 3 is minus 18y is equal to 9. And take this second equation, that is 9x minus 20y is equal to 1. Okay, this is you compare 18 and 20, it is smaller, so subtract this equation from this. Okay, so what do you get from here? You get, or if you subtract this from this, you get plus 2y. So 2y. Okay, when you subtract these two get cancelled, this minus becomes plus, right? I am subtracting this from this, so this minus becomes plus. Minus 18 plus 20 is 2 into y is 9 minus 1 is 8. So this gives y equal to 4. Okay, I have subtracted this from this. 9x cancel, minus becomes plus. Okay, and then minus 18 plus 20 is 2y. This becomes minus 9 minus 1 is 8. Therefore, y gives y cancel 2 on both sides, you get y equal to 4. Substitute this in this. So 1 implies 3x minus 6 into y. Substitute y equal to 4 in this is equal to 3. So this gives you what? Right? This gives you 3x minus 24 is equal to 3, right? So take 24 to the other side, you get 3x is 27, means x is 9. Okay, therefore the required number is x into y. Y is equal to, in place of x you have to take 9, and in place of y you have to take 4. Okay, so this is your number 94, right? So what is the required number? That is xy, that is xy means x in tens place. See, this is not x into y. The x is, I am taking x as a digit in tens place. So x is 9, so write it in tens place, and y is 4, it is digit, write it in units place. So the number, two digit number that we are looking for is 94. Okay, you may verify if you want. Yeah, what is sum of these two is 13 into 7 is 91 plus 3 is 94. Okay, similarly, what is difference of these two? It is 5, 7, 19 into 5. 19 into 5 is 95. 95 minus 1 is 94. So our solution is correct. Okay, so this completes the solution. So what we have done, yeah, we are looking for a two-decimal number xy such that that number is 7 times sum of the digits plus 3 more than that, 3 more than the 7 times sum of the digits, and 1 less than the 19 times of the difference of the digits. Okay, so take the required number to be xy. Here you are not taking x and y as some product. Your xy is not product. They are digits. They are values between this x is value between 1 and 9, y is value between 0 and 9. So they are digits. Okay, two decimal number. Xy is a two decimal number, and the relationship, what is the place value of, what is the number value of this number? X is in tens place, so multiplied by place value. This is x. That is x into 10 plus y is in units place, multiplied by 1, you get 10x plus y. This is the number value of this number. And it is 7 times of the sum of the digits, and 3 more than the 7 times sum of the digits. So from here you have simplified this. That's you have got a linear equation. Similarly, another equation is that this digit, this number, that is 10x plus y, 10x plus y is 1 less than 19 times of the difference of those digits. Difference means x minus y. You are given x is greater than y. So x minus y is right. You take x minus y, and then you have 19 times of this with 1 less is equal to the number value. So this gives another equation. This gives a second equation in x and y. Right. The first relation gives this first equation in x and y. The second relation gives second equation in x and y. This is a system of equations. You solve for x and y by any method you like. Okay, you have got x equal to 9, y equal to 4. Substitute them in this. This is a digit. Substitute 9 in place of x, y in place of y, in place of 4 in place of y. This is 94. 94 is a two digital number. You have to take this as a two digital number. Okay, so that's how we have to take x. This is not x into y. It is x y with the x in tens place and y in units place. Okay, so the required number is 94. This completes the solution. Next time we'll continue with the next problem. Thank you. Goodbye.